Hi, and today we're going to talk a little bit about random sampling and why it's necessary. So we start out by saying that random selection, it's really the only way that a statistician has to guarantee that you get an unbiased sample. We want there to be no slant in what we're talking about. We want to make sure that we get the best unbiased representative. That's just saying, your sample is supposed to look like the population. It's supposed to give you a snapshot of the population, and randomness is the way to guarantee that that happens. We're going to talk about several different types of sampling today, and we're going to start with the idea of a simple random sample, sometimes called an SRS. So if you see me use those initials, that's what I mean, simple random sample. In a simple random sample, each member of the population, or each unit, and each n-sized, so if you pick a value for that variable, each n-sized group in the population has an equal likelihood of being selected. Has an equal likelihood of being selected. Let me explain what I mean there. We get the idea of each member of the population. We get that. Each unit should have an equal likelihood of being selected. But this whole each n-sized group, what does that mean? Well, let me see if I can put it to you this way. Suppose that you had, or take for example the D wing in our high school, where each classroom has about 28 to 30 people in it, a little bit more than that in some classes. However, if I go through the hallway and I number each student and pick, say, 50 of them at random, that's good. Each person had an equal likelihood of being selected. But if I changed my selection method and said, okay, I'm going to pick just 5 people from each classroom, then folks, each person still has an equal likelihood of being selected. However, each group of people does not, because if I'm only picking 5 from a classroom, then there are groups of 10 people, say, that cannot be selected because I've limited what I'm doing. Each unit and each group has to have an equal likelihood of being selected, and that is a true simple random sample. To choose a simple random sample, what you do is that you begin by making a list of each unit in the sampling frame or in the population. That term sampling frame, that's come up a couple of times. Again, all that is a frame. The sampling frame is the list of all the units in the population. Okay, so all units in the population. Then you give each unit a number, and you select randomly. Until you have the sample size that you need. Well, that doesn't sound too bad, right? Kind of like pulling numbers out of a hat. That's exactly what it is. You make a list of everybody in the population, you number each of those units, and you select randomly one by one until you have the sample size that you need. Okay? That's a simple random sample. A related way to sample is called stratified random sampling. And in a stratified random sample, the population is divided into groups based on some characteristic. And once you have, based on a characteristic, Once you have your population divided, then you pick a simple random sample from each of the groups. Pick a simple random sample from each group. And stratified, you can think strata is layers, so you're layering your population based on a characteristic. Why would a statistician choose to do this? Well, for one thing, it is the convenience. It's easier to sample from smaller groups. Okay, and that just makes sense. Also, there is the idea of coverage. Folks, if you think about this, you are guaranteed to get responses from each layer in your stratified sample. So you're guaranteed to get input from each group. And the last reason was kind of surprising to me, precision. And it's been shown several times, many times, that data gathered in a stratified random sample, it's more likely to look like the real population. So it gives you that better chance at getting a representative sample. Representative sample. And I guess the word get should be in there. More likely to get a representative sample. I found that surprising when I heard about this. So if you think about this, some ways that groups might be stratified or layered, it could be gender, could be age, could be class, right? If we're talking about high school, it's a characteristic of the population, all right? That's stratified random sampling. The next of our sampling methods, cluster sampling. In this case, the population is also divided, but it's divided by geographic location. So if you think about this, within the state of Michigan, if we wanted to cluster sample, we would think about counties, because that's a geographic region inside the bigger region state. Once you've divided by that geographic location, so those are the clusters, then you pick a simple random sample of the clusters and you census inside each of those that has been selected. You pick a simple random sample of clusters and census each one. So maybe they pick 20 counties in Michigan, but in those 20 counties they'd census, they'd talk to each taxpayer inside. Okay, that's a cluster sample, and the key is divided by geographic location. So if you're trying to figure the difference between stratified and cluster, think stratified is about characteristics of people. Cluster is about locations of people. A two-stage cluster sample is related, folks. Again, the population is divided by geographic location. Into clusters. Then randomly selected clusters. Have a simple random sample drawn. So really the only difference between here and here you census, here you simple random sample. Okay, so this one's going to get input from everybody in each cluster. This one is going to get input from randomly selected units within each cluster. The last of the types of sampling that we want to talk about today is called systematic samples with a random start. I've seen this defined in two ways, so I'll try and talk about both ways. You divide the population here as well, but you divide the population into groups of the desired sample size. And you might do that, groups of the desired size, by numbering off. So think about it like in gym class or whatever. 1, 2, 3, 4, 1, 2, 3, 4. You divide the population into groups of the desired size by numbering off. Then randomly select one of those groups to be your sample. If we were going to use this strategy here in your senior class, for example, you have roughly 250 students in your senior class. If we wanted to have groups of 25, you divide by 25 to see how many groups you would have, and that would be 10. You would number from 1 to 10 as many times as you could from your group of seniors. Number from 1 to 10 and go through the group. You will have divided it up into 10 groups of 25 people, and you randomly select one of those 10 groups to use as your sample. Okay? An alternate method of selecting a systematic sample that I've seen in other textbooks, ours doesn't mention this except very briefly. They say if you wanted to get a sample size n, like 50 perhaps, pick a random number between 1 and 50 and call it whatever. Maybe it's 12 that you picked. Then beginning with that 12th unit, select every 50th one. Okay, that would get you the same thing as this. Okay? It's just a different way of setting it up. Here you divide into groups and pick a group, but here you're saying I'm making my group up by picking every 12th person. Okay, they're very, very similar methods. All right, I'm going to ask you to do a what if with me, and I'd love to have you stop the video and then think about this. If you were going to use each of today's methods to generate a random sample, how would you do that here at Clio High School? This is good practice, actually. The things you have to cover are, how do I take a simple random sample? How could I stratify? How could I cluster sample? How could I two-stage cluster? And then how could I do a systematic sample? Let's pause that video. I'll show you my thoughts, except you already heard quite a few of them. All right, I'll catch up with you in a minute. If we're doing a simple random sample in our high school, we'd have to give each student a number. And select randomly. So select numbers, which represent students at random. If we wanted to stratify here at the high school, a good way to do it is by class. Divide by class. And take a simple random sample from each class. If we wanted to do a cluster sample at the high school, you might divide the school by geographic location, divide by hallway, right? Think about the hallways as being, or maybe sides of each hallway, as being a cluster. Select random clusters and census. So ask each kid, right, in the selected hallways. If we wanted to do a two-stage cluster, we would divide by hallway, perhaps. We'd select random clusters. And then do an SRS in each cluster that was selected. To do a systematic sampling, I want a sample size 20, so I pick a random number between 1 and 20. Say 5. And starting with person 5, pick every 20th after that. Alright, that's my thoughts. I hope they match yours. And if they don't, we'll discuss it in school tomorrow. Get out there and try the U-Try.